Okay, here we are. All right, welcome to week 4. Tonight's joins, we've already had a couple of in our pre-class conversations about self joins and joining the same table. We're going to talk about that a little bit. Again, this will be the last week where I really don't jump into the deep dive of ERDs. That's going to be starting next week because I like talking about joins and there's a lot to cover, a lot of meat on the bone to cover here. So before I begin, are there any questions of last week's work, last week's assignments? Any questions, comments, concerns on anything from last week? I'm going to take that as a big...
I'm just more concerned to make sure I'm on the right track for my project. If I get started on the wrong foot, it's going to be a devil to fix.
No, I mean, right now you should right now with your project, you should just be coming up with a concept and designing the diagram and getting your tables down. If you're doing that, you're in the right place. And we'll have some time at the end to talk about it real quick.
Like I got a question regarding is the project a group or an individual?
Individual.
Okay.
Individual. We did a long time ago when I first started teaching class, we did group stuff, and group stuff barely works in a classroom setting. Never mind trying to do it in an online setting. So we don't do group stuff. Okay. So yeah, it is an individual project. And Phil, right now, as long as you've got your idea and you're starting to like design your ERD and get some tables down, just because we don't talk about it on Wednesday night, if you want to shoot me emails or like shoot me like texts of what the tables look like, I can help you walk through that stuff. It's not a big deal. So next week, so this week is the big week. We're going to talk about joins and how they work. And next week, it's like unions and little stuff. But next week on Wednesday night, what we're going to do is after we talk about the code and stuff, I'm going to walk you guys through how I design a database from the beginning to the end. And a lot of y'all, I mean, the week 2 assignments, the reverse engineer, I got to say, people came up with some really cool stuff to reverse engineer. Usually someone tries to do like the church genealogy website and then their heads explode because there's just like too much there. But no one did that, which was fantastic. But people came up with some really cool ideas, and I've got 1 or 2 of them where I'm going to like kind of show how to design, start with a database and kind of build out with that. Okay. So Philip, do you have your idea for your database right now?
Do I have my idea for my project database?
Yep.
I did post that.
Okay.
I did turn that in. Could end up getting kind of complex.
Okay. Well, I will. That's my job to keep you not getting complex. I will rein you in. Okay.
Okay.
I have yet to have someone not pass the final project. Okay. So I got you. You'll be fine. I don't know if you've noticed this or not, but I tend not to grade the assignments until Friday or Saturday because I want to make sure everyone gets their stuff in, because I hate going back and grading late work. I will do it until week 12, but I don't like doing it. So I give everyone the ample opportunity to get things turned in. So I'll grade the week 3 stuff probably tomorrow or Friday, and I'll read through everything and see what's going on with your stuff. And then I'll give you the feedback based on that. But if you've got to, just start when you're starting designing the tables, you'll know when it gets too complicated. When that happens, just stop and then like send me a picture of what you've got, and then we'll talk through it. And I'm always open for one-on-one sessions. I sit in front of a computer all day, every day. I'm in the Eastern time zone. I'm on the computer from 8 a.m. in the morning to about 5 p.m. in the afternoon. So if you guys ever need to jump on, text me, shoot me an email, and I'll open up Teams or something, and we can chat. Okay. Or Zoom or whatever. I used to use Slack, but I'm finding just keeping Teams open, or not Teams, but keeping Zoom open works best for me. And then people will Google me through Google Chat, which is another way to get hold of me. Okay, so let me do this here. Okay, so today we're going to talk about joins. So we talked about, and let's start drawing things here. we talked about how entity relationship databases are about having multiple tables that actually I can, no, that's fine. Having multiple tables that each house a specific set of data for like this. So this might be my customer table, right? And this might be my orders table. And this might be my inventory table. Right? And so on and so forth. So each table has data that only deals with what that table is about. So the customer table will only have data about the customer. The inventory will only have inventory. It will not have stuff that is not about them. Okay. So then the question is, when we have all these individualized, compact, isolated capsules of data, how do we get them to talk to each other? Well, who here remembers Venn diagrams from elementary school? Anyone? A little bit? Okay. So let me erase everything.
My elementary school was so far back, I'm pretty sure they didn't know what a Venn diagram was, but I'm dating myself.
I'm 52. What are you at?
56, 57.
Okay.
I forget.
We're not that far off. So I definitely have Venn diagram. So it might just be a little bit. So a Venn diagram looks like this. And here, so I've got this one circle, right? And then I got another circle. Oh no, those are right here. So this is my Venn diagram. It's a really, there we are. Okay. So this one here is, we'll call this
Inventory table.
We'll call it, yeah, so this was the inventory, right? So we'll call this inventory. Inventory. We'll call those orders, the orders, right? Call those orders, and we'll call this one customer, right? So now everything in this circle here is customer data. Everything in this circle here is order data. Everything in here, if I can find my little drawy thing, everything in here is customers who have placed orders. So where these two overlap, right, it's where the data overlaps. So in here, we're going to find every customer who placed an order. Well, did that fade for everybody, or is that just me? Oh, it's a vanishing pen. How wild is that? I've never seen that before. Okay, that's fun. I didn't want that to happen, but okay. Where is, I don't want to finish it. I just want a regular pen. That is a magic eraser. This is working. That's fine. Oh, you know why? Because I forgot. Okay, so this is what I want here. And then I want to go back to this here. Okay. So this is what I like to do. So here. Nope. Oh. There's one. Okay, so, and then I have this here. So I can do this. Boom. Boom. No. Boom. There you are. And then here. Okay. So over here, I've got my orders table. Over here, I've got my customers. We're doing low-tech MS Paint here. All right, customers. Okay, and then in here, this area, this green area, are all the orders the customers have done. So this is where the data overlaps. Okay, so this is the fundamentals of a join. Okay, so there are basically three kinds of joins. There's inner joins, there's left outer, and there's right outer. Okay. Okay. And I'm going to demonstrate a couple of these tonight. The inner join is when I take, so the inner join is when I join two or more tables on columns they have in common, and the results I get back are evidence of data where it exists in all the tables. Okay, so here in this example, if I wrote an inner join based on the orders customers, anything in here would be customers who placed orders. Okay. And that's all. If I have 15,000 customers and 15,000 orders, but I've only got 1,200 customers who placed orders, right? The results of that table are only going to be 1,200. Now, I'll show you some code. This is just kind of laying the groundwork here. I'll show you some code in a minute that explains this better. So when you talk about outer joins, okay, what an outer join does, it returns all the results of one table plus the data that matches from the other table. For example, and left or right depends on which side the table is on. So here, if I want to do a left outer join, I'd be joining the orders table with the customers. So I would return all of the orders, and then I would get values for whatever customers placed orders. Okay. If you don't understand, it's totally fine. If I did a right join, I'd be joining the customers table and showing all the customers, but only the orders where the customers placed order, the orders were placed. Okay. So that's the groundwork for that. That's what this is. I'm going to show you code. It's going to make a lot more sense. Yes, Nicholas.
Like there's I think 4 of them, at least full. And what about full outer join?
Okay, full outer join doesn't exist in MySQL. You cannot do a full outer join in MySQL. It doesn't exist.
Oh, okay.
What a full outer join does, it joins both these tables together and returns everything on both sides. But, and so this is one of those times where, one of 5 times this semester where something's going to be shown to you and explained to you, but doesn't actually work in MySQL. Full outer joins do not work in MySQL. Okay. They work in MS SQL. They work in Oracle. They work in Postgres. They work in MariaDB. They do not work in this version of MySQL. The other one is called a cross join. And cross joins are useless. Don't ever use them. I will show you what they are, answer the questions about them, but you will never, ever, I've been doing this 22 plus years. I have never used a cross join in an actual query other than to explain what a cross join is and why never to use it. All right. Did that answer your question, Nicholas?
Yep.
Yeah. Okay. Okay. So let's move on to the code. So I should be able to, does everyone see my code here?
Yes.
Okay.
Yes.
So what a cross join does, so select last name first. So a couple things about the anatomy of this. I think we talked about this last week. You'll see I've got like this A dot last name, A dot first name, B dot address, and then down here as from customer A, cross join customer addresses B. Whenever you're writing a join and you have got columns in the select query or in the order by query, wherever you're naming columns, you need to specify to the engine where that column is coming from, particularly if that column exists in multiple places. Because if I had last name in more than one table I was using in my from clauses, the query wouldn't know where to look for which last name clause, which last name column to use. So I've got to tell it by using an alias in front of it, saying customer A, so A last name, A first name, B address, and here are my aliases. So I know the customer table is known as A. The address table is known as B. It could be whatever you want. If you didn't put A or B, you would just need to put like customer here. So this is a valid way too. This is a lot of typing, but that works too. Okay. So I'm going to run this. So this is selecting last name, first name, address from customer as A, cross joining address as B, and I'm ordering by last name. And if I run this, you'll see that Raphael Abney lives at 1103 Quimlis Boulevard. Raphael Abney lives at 1331 Usac Boulevard. Raphael Abney lives at 1325 Fukuyama Street. So what cross join does, it is a cardinal join. It joins everything in the first table to everything in the second table. So Raphael Abney will pair with every address in the address table. And when that's done, the next one will happen. I'll scroll down here. So it's got 1,000 rows returned, but let's see. So next one is Nathaniel Adam. And Nathaniel Adam also lives at the exact same addresses that Raphael Abney does. Let me get back to the yeah. Okay. So what happens is, so here's like there's Xantum Lane. Okay.
This is what the reading called Cartesian.
Yeah, Cartesian or cardinal.
Okay.
Yeah, it's Cartesian. It's a Cartesian joint, which is why we never use it. There's no rational reason to ever use this type of join. It just matches everything up with everything else. All right, so there you go. And we'll look at now. This is the anatomy of a proper inner join. Okay. We're doing a select statement. We're doing last name, first name. We're doing address. We're using the customer table, and we're interjoining the address table. And then we do this. We tell it what column to join on. So we're saying, I want you to join these two tables and do it where everything in this column matches. And this is the address ID column. Because if we look at our customer table over here, our customer table has an address ID. Our address table has an address ID. Okay. So that's why we're joining them there. Now, 99% of the time, 99% of the time, this column is going to be a foreign key. What a foreign key is a type of constraint. A foreign key says, if I've got the customer table and it's foreign key to the address table, okay, it says nothing can exist in the customer table in the address ID column that doesn't exist in the address table in the address ID column. Okay. If it does not exist here, it cannot be here. Why do you think that is? Why does it have to exist here to exist here? Because if it doesn't, we won't have a valid address for the customer. If there's a valid ID in here, it's got an address, it can go here. But we don't want people. So part of designing databases is to make sure the data is clean and concise and can be read clearly. We want to make sure that people can't fat finger things and misspell things and do all sorts of oddnesses, right? So we want to make sure that if we put an address in for a customer, it exists in the address table. We don't want someone just randomly typing in a number there that doesn't exist. Okay. Nicholas, you had a question? You went off mute.
Yeah, not a question, just a little comment. Maybe this is also referring to the cascading type of work when you, for example, try to write the data, you have to implement it in that way that it will cascade, inject the data.
Right. So the cascade command is, excuse me. You're absolutely right. This has to do with cascading. The cascade command is a little beyond our pay grade in this class, but you're right. You're right. You want the data to cascade down. So let me run this query. And here we go. Now we find out that Raphael Abney lives at 48 Maracaibo Place, and Nathaniel Adam lives at 78 Matsui Way. So now we have a rational and reasonable way of looking at things, that we have actual data that is being worked across. Okay, does that make sense? Is everyone with me on this? Anyone lost? Morgan, Philip, we're good?
Yeah, I'm good.
All right.
I'm good.
All right. So let's take this a step further. We have a customer table, we have an address table, and we have a city table. We're going to get the last and first name, we're going to get the address, and we're going to get the city. We're going to join these two, customer address on address ID, and then we're going to join city to the address table, because in the address table, we've got city ID. So inner join address B on address on an A address ID equals B address ID. Inner join city C on B.city ID equals C.city ID, order by name. So this is going to show me, first it's going to grab all of these that match, and then it's going to add all of these that match. And it's the same result, it just adds the city to it now too. So nothing has changed. We're just adding the cities to it now. So this is all about how to get data from multiple tables into a viewable and workable version of data that people can read and understand. Okay. So let's look at this one. We're selecting the last name of the customer. And we get a little caveat here. I'm doing this as, when I do this as and add another value here, I'm renaming this column in the output. So I'm selecting the last name column of the actor table, the customer table, and I'm calling customer last name. I'm selecting the last name of the staff member and calling it staff last name. Okay. I'm getting the title of the film from the film table, and I'm getting the date of the rental. So the purpose of this query is I'm going to get the last name of the person who rented the movie, the last name of the staff member who helped them rent the movie, the title of the movie they rented, and the date they rented it. So here I'm interjoining the rental and customer table because customer ID exists in both. I'm joining the staff table because staff ID exists in rental ID, in rental table and staff table. And then I'm adding the inventory table so I can get the inventory ID of the film. Okay. Because I want to get the film name, the film ID. If I go to the film table here, this is a little complicated, but I think you guys are good. If I go to the film table, here's the film title, the film ID, right? The only other place film ID appears is in the inventory table. So here's film ID and here's inventory ID, right? I want the title of the film to show up here. So the only way for that to happen is in my series of inner joins, I have to link the inventory table, even though I'm not selecting any columns from it in my select query. I still need it for the join to get the data over there. Because I can't directly connect the film table to the rental table. Because if I look at the rental table, rental ID, rental date, inventory ID, customer ID, return date, staff ID, last update. Film ID is not there. I can't get the film name from the rental table. I can only get the film name from the inventory table. So I've got to put this inner join there. And then finally, I'm going to join the film table on film ID. So let's take a look at the results of this one. Harder, Hilliard, okay. So here's my results. Customer last name, staff last name, film title, and when they rented it.
Does it ever matter what order you join them in?
Sometimes it does. Not always, but sometimes it does.
Okay.
I generally, when I do the joins, I do from top down here. I do my select statement first, and then do my joins based on that. Sometimes, and this is rare occasions, when you're doing mathematical computations in your select queries or aggregations in your select queries, how the numbers come in make a difference. But for the most part, when you're just doing concatenations like this, it doesn't make a difference. So does everyone see how this data flows? Okay. So now here's another inner join. But if you'll notice, I'm doing something a little different here. I'm inner joining a subquery. Which I can totally do. I'm getting the last name of the actor and the film title. I'm joining the actor table to the film actor table on actor ID. And then I'm joining that to the film table where movies are PG. So this query here just brings back all the PG movies. So this is an example. This is just an example showing that you can, in fact, use a subquery in your joins to get the data that you want as opposed to finding a table. There are other ways to do this with the PG. This is just a demo on how that you can put a subquery in here. So here, if we look at our results to this, a lot of people are in Academy Dinosaur. Apparently, it's a very popular movie. Okay. So you see how we can, like other places with from clauses, we can put subqueries in and make them work in lieu of tables.
Well, that's because the subquery is generating a temporary table.
Yeah, it's generating results. Yeah. Yeah, absolutely. I don't like this. This can complicate things, so I tend not to like do it unless I have to, but it's just an example of what you can do. Okay, we've already been through that. There's some other stuff. We've done all this stuff here. This is all duplicates. Okay. Yep. 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 What's this one? Oh my gosh. Oh, okay, that's fun. So here's a crazy one. What was I thinking when I wrote this one? Let's take a look at this one. I want to do. That's all right. So let's look at this one. Select month name as rental date as month. Title, count as number of rentals, firm rental, interadjoining inventory on inventory ID, interadjoining film on film ID, interadjoining film category on film ID, interadjoining why did I do this? Month name, no. I'm sure I had a good reason, but this is saying in the month of August, Dinosaur Decorators rented 13 times. In the month of August, Dorado Nyling was rented 13 times. So I had in my head to write this query. I don't remember why I did this, but that's a super fun, complicated interjoin for you. But what this would be a good example of, I guess the reason I did this is a good example of what a case study would be. I need to see what movies were rented in the month of August. And here I am. This tells me that the Sinners Atlantis was rented 8 times in August. Tracy Cider was rented 8 times in August. Okay. When we're looking at our projects and we're doing our case studies, basically a case study or a user study or anything like those is basically saying, why are we using this data and how are we using it? What would we do to use this data? So we might have a case where we need to know what movies were rented in what month. And this would give us that data. So here's August, and then there's probably September, February. Yeah. Okay. Now, okay. So any questions on any of this stuff? No, everyone good? Philip, Nicholas, Morgan. Hey, Pearl.
Yeah.
Okay.
Okay. Okay. So now, in the pre-conversation before we started recording, 2 questions came up. One, why would you join a table to itself? And the other, there's something called a self join, and they're the same, but they're different. So this actually, I think this is the answer to one of your quiz questions this week, if I'm not mistaken. Basically, we're taking this query. Anyone have any idea what this query does? Who wants to take a guess to what this query does?
Does it compare the 2 addresses?
It compares the 2 addresses. And basically what it does, it shows 2 addresses that are in the same city, but aren't the same address. So here, select address from address, joining address A on interjoin address 2, where city ID equals city ID, but where address doesn't equal address. So it's showing 2 addresses that are in the same city but aren't the same address. So these 2 addresses are in the same city but aren't the same address. And here's the reverse of them. Okay. That's all this was doing.
In the question, I think if I wrote it down right, it had like A1 address, and then it had ADDR1.
Oh yeah.
What the heck is the ADDR1?
I'd have to see what they're talking about, but it was this. It was that.
Yeah, but it came after it said A1 dot address, and then a space, and then it said ADDR1,
Oh,
and then a comma.
that.
Yeah. And then the second one had ADDR2.
It's just the column header.
Oh,
It's just changing the column header.
so you don't have to say as?
I always do that because it's clearer to me,
Yeah.
but you don't have to.
Oh,
Anytime you see a value after a column name in a select statement, that's usually aliasing the column
Oh.
name to something else.
okay. That makes more sense.
Yeah. So they probably did this here.
Yeah.
So the reason why you would join a table to itself, let's say, for example, you've got an employees table, right? And in the employees table, you've got the employee's job designation, right? And one of the job designations might be manager. Okay. And in the employees table, you might have manager ID. Okay. So that manager ID that's in so that manager ID in the let me do this. Hang on. I don't want to confuse you guys, but I want to make sure you get this. I could do it here too, I think. No, come back over here. No, let's just this here. Okay. I'll just do it. Sometimes I'll do, you guys did this too. I saw you guys do this. So I have the customer table, right? I have that employee table. Okay. And in the employee table, I've got employee ID, I've got last name, I've got first name, I've got job code, and I've got manager, right? Okay. So now the manager ID, okay, is going to loop back to the employee ID here. So whoever is the manager, whoever manages people, their ID is going to be here. So I would have like, one Joe Jones, and then his job code is 6, and his manager ID is 5. And then 2 will be Bobby. He's from the South. And his job code is 5, then his manager ID is 5. And then down here I'll have 5 George Jetson. And his job code is 1 because that's manager. And then he doesn't have a manager. So that's null. Or his manager is someone else because like he's a senior manager, right? So if I want to write a query on who someone's manager was, I'd write something there like select last name, first name for manager from employee, inner join employee, where manager ID equals employee ID. And then that's how I would get that out. Is this making sense? I don't have a good example for this because
Yeah, I got
it's not built into the program here. But that's why you do it. So sometimes when you have like an employee table, like with the employee table, you have the manager ID will be the employee ID, so it'll reference back to itself. The danger about this is, so let me see if I can explain this one here. I've got this one here, and this is a table that this is what I call a cautionary tale of databases. So the problem with a table referencing itself, okay, let's say we've got a dog breeding business, okay, and we've got a dogs table. And in there we've got the dog's name, right? And then in there we've got the dog's father. We got a table that's got the dog's father and the dog's mother, right? And remember I was talking about foreign keys, right? So every animal we have has to have a father and a mother. And so we've taken this dog table and foreign keyed it to itself. So I've got dog. Let me do this in Paint here instead. No. Let's do this over here. No, I want to create a just don't create a new model. Well, okay. So add diagram. Okay. So I'm gonna create a table here. Come on. There, okay. I'm call this table dogs. Come on, there. Okay. So the column is gonna be dog ID. And then we want dog name. This is kind of a deep dive thing for me because this is one of those things that I like to try to explain as to why it's a bad idea to do, but it can get confusing. So if I confuse anybody, I deeply apologize for what's about to happen. Mom ID. Okay. And then over there, we're going to choose that to an ID, change that to an int. And we want another one, we want dad ID. So we got this here, right? So we've got the dog ID, the dog name, the mom ID, and the dad ID. Now, we can theoretically
Should you change the dad ID to an int also?
oh, Stan, thank you, thank you. Yes, I should change the ID to int as well. Int, okay. So, okay, so we're gonna do that. And then we're going to do another one where mom ID to dog ID. Okay. So now we have basically, so I'm trying to foreign key here. Yeah, okay, cancel, that's fine. Okay, so I basically have done it to where this is kind of messy, but I've foreign keyed dad ID to dog ID, and I've foreign keyed mom ID to dog ID. Everyone follow me so far?
Yeah.
And remember what I said about foreign keys? If the data doesn't exist in the table, it can't exist in the other table. So I've basically made it so I can never put data into this table, because I'm never going to have the mom and dad ID and all the kids at the same time with the foreign keys here. But this is why I would do this with the self-joining tables, is if I was doing the dog breeding thing, I'd have my dog name and then my mom and dad IDs, and then I would link this back up. And if you look at the query here that I wrote on this completely fake query, I was over here a second. Yep. Select dog name is child, foreign key dog name is F dog name is father, M dog name is mother. From dog C, inner join dogs is F, where dad ID equals dog ID, inner join dogs is M, mom ID equals dog ID. So this is why I would self-join the table, because all the data is in one table. And it's one of those things where it makes sense to be in one table, but it can get confusing because it's in one table. And how many people did I just completely lose?
Wouldn't it be better to use a multiple many-to-many relationship, like a different table that would just manage even for the same table where we are using all dogs?
So I see where you're going with this. So here's the thing. The rules of normalization state that no data should be duplicated anywhere else. Okay. So we could theoretically create some temporary tables and pull all the dad dogs out and all the mom dogs out into temporary tables, but we wouldn't create separate tables for mom dogs and dad dogs. All the dogs
No,
have to,
I meant about the IDs only. I don't duplicate, for example, any data.
oh, I
like,
see what you're
because
saying. So what you're saying is I would create another table. So what you're saying is, okay, yeah, you could do that. It doesn't go with the example I was explaining, but yeah, that you could totally do that. So here, you could do here and say, you get rid of this here. I see what
Like a
you're saying.
relationship table.
Yeah, you do relationship table. Yeah, you could do
Yeah.
that, and that's a smarter way to do it. I was just explaining why you would. Some people would do it this way.
because I've seen such example in production database, and I felt it's super awful because it decreased the
Oh, yeah.
performance in several decades of times.
So here's and I agree. So I've worked on some data. I worked on some databases, and what happens is, people get in their head an idea on how to do something, and they'll do it the way that makes the most sense to do. It's not necessarily the right way to do it. And then what'll happen is that's the way it'll exist for 5 or 6 years, and there'll be data and more data and more data and more data. And then what'll happen is to change it becomes too much of an effort than just leave it the way it is. So to your point, Nicholas, this is a design issue, and this is why design the ERDs is so important, because you want to make sure you're making good design choices at the beginning. Like saying we're going to make a separate table for dog genealogy, as opposed to putting everything into the same table, right? So, and I agree with you that having the separate table for that makes sense. I was just trying to explain why we would do this. And that there are a number of databases that people do this on purpose and think it's a good idea. So, but yeah. But Phil, does that explain why people would join the same table to itself?
Oh yeah, I got it.
Yeah. And that's what this is all about. I mean, I would never design it this way. But this is why they would do that. And really, if I saw this, I would change the database no matter what it took. I think I told you the story. So one of the first jobs I had as DBA, and this is why, and I don't think I've given you guys the video on, did I give you guys the video on data types yet to watch? Has anyone watched the video on data types from me yet?
I can't think of one.
Okay, there's one coming up. I talk about data types are incredibly important. And this is kind of to Nicholas' points about designing from the beginning to do it the right way. So we know that here we've got so it's not, so they don't have any, so we have int, and we've got small int, we've got tiny int, right? There's also, and there's big int. So there's 4 choices, and int, if I remember, a tiny int is 0 to 255. Small int is something to like 20, couple 100,000, something like that. And then int is like 2.1 million, and big int is ridiculously numbers, right? So whatever the numbers are, but they go from small, tiny, small int. And so, and the difference is this is 2 bits, this is 4 bits, this is 8 bits, and this is 16 bits. So the first thing about data types that's important to remember is that when we create a column in a database, and we assign a data type to it, and it's like an int or something that's set, if we set a column that's big int, every column that's created will have 16 bits in it, which doesn't seem like a big deal until you got like, 17 million rows, and then it becomes a pretty big deal. The point being is I worked on a database, and when they created it 10 years prior, they used the int field as the ID column, never thinking that they would surpass 2.1 billion rows. 10 years later, they were 97% saturated with IDs. And so we had to convert that ID column from an int to a big int. And what happened was it caused the table to grow 87% bigger because of the change in size of the value. And it took the better part of 5 days to do. So to Nicholas's point, when you're looking at stuff like this, even though this was just an example explaining why you would do it, how you design your database is extremely important. You need to make sure it's got scalability and flexibility and nothing that's going to cause you problems in the long run, like tables joining themselves. Does that?
How would you know which one of those to use though? Because I mean, if you're not anticipating getting that big, I mean, you don't want to waste all that extra space, right? With the
Well,
large int.
and that's a really good point. So you have to say yourself, say, you know, so the company I was working for was a title insurance company. And their model was going to be, they were going to go to every state, every county in the country and get all of their property surveys from them and put them in. So at that point in time, someone should have said, hey, there's gonna be a lot of these. If you're gonna do if you're doing like a small bookstore, right, and you're not planning on growing past the bookstore and whatnot, then you can say, you know what, I could probably go int, maybe tiny, small int, based on what my projections are. The other thing is, and this is a long-term thing as well, it's important to reevaluate your design every couple of years to make sure it's still functioning as as necessary. So for example, let's say, you know, we all got together and started a small bookstore. It wasn't gonna be a big deal, but like all of a sudden we became super popular and we went from like having 1 store to 15 stores, right? And we're using a centralized database. Suddenly, you know, we're like, hey, we got to fix this now versus wait. Okay. So a lot of times it's just your best guess based on the business model that you're trying to design for. But the other times it's being able to grow and being agile and understanding the change of the business so you can make changes to the database before it becomes a catastrophic problem like we had. Right.
So you're saying it's okay to build it the way you think it should be, but modify it if you need to, but don't wait too long.
Absolutely. Yeah. It's all about educated guesses. It's all about looking at it going, okay, you know, when that company for title insurance, whose goal was to have every property survey in the country in their database, that was their goal. That was the written agenda that they had. They should have realized that int wasn't going to cut it, and they should have gone big in from the start.
Got it.
So there's a lot to design a database. I see your hand there, Nicholas. I'll get to you in a second. There's a lot to design database. I mean, there's, you know, when you're designing a database, you got to sit down with the owners of the business and say, what are you expecting? What do you want? What are the goals and things like that? But it's really this balancing process of doing your best guess as to what's going to work, but also being agile enough to make changes on the fly, saying, wait a second, you know, this isn't going to fly. This isn't going to work. Because 10 years ago, there was a data type called blob. And it just, you just put anything in there and it was fine. But Oracle and Microsoft SQL Server and all of them said in 3 years, this data type is going away. And no one listened. And then the new version of the operations, the database system came out, and that data type was gone, and everyone was struggling trying to fix it. All right. So this is a job, a world where you've really got to be aware of what's going on around you and making good choices at the start, but continue to make the good choices and changes to go along. What was your question, Nicholas?
It was more question, like more comment
Sure.
regarding the changing database, like on the way or on the fly during the runtime. I wouldn't expect that the customer will allow you to change database in any time. It's cost too much. For example, I get a real example where the customer run on the same database for a long ride,
Mhm.
about 15 years. And they like, when I found some kind of issue that decreased their performance, they won't allow me to fix it because it's too much efforts need to be to fix that.
Yeah, and that's another funny conversation when a database blatantly doesn't work, but the customer can't afford to fix it. That's when one or two things happen. You as a DBA or database engineer or whatever it is, you sit them down and say, hey, here's what's going to happen if you don't fix this. And then if they listen to you and they don't change it, you just get an email from them or something signed by them saying they understand that this is broken, and then when it crashes, it's their fault, and to leave you alone when it breaks. In my job now, I have a lot of that. I have a lot of people saying that I am the main architect for database as a service. So I design the architecture and topology for all of the Oracle, MySQL, Microsoft SQL Server systems. And I also maintain and monitor the existing architectures that are out there. And so part of my job is to reevaluate architectures over the course of time and make recommendations to fix, change, or modify based on coming trends, based on deprecations coming in database systems, based on workload coming in and things like that. So you can only do so much to the customer. You will sometimes have customers who absolutely refuse to change anything. Up until 2 years ago, I had an application running on SQL Server 2000, which is just the most absurd thing ever. But the customer refused to change, and no one forced them to change. So I basically told them that I'm not helping you anymore, and have fun. And lo and behold, 2 weeks later, something broke, and I didn't help them, and they fixed it. So I get what you're saying, Nicholas. Customers don't want to change because they're very used to what they're doing, and they don't see the value in upgrading or repairing, or the term. Anyone familiar with the term ROI?
Yep.
Yeah.
Return on investment.
Return on investment. They don't see the ROI as being very high. They don't see investing 35 hours and a couple $100 on an application to fix it, to make it run better, worth it, because they don't want to spend the $100 now. So yeah. I feel your pain on that, Nicholas. Customers can be very, 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 I can't think of an appropriate word.
I think you want to say stubborn.
Stubborn's a good word. I like stubborn. Short-sighted. Short-sighted is a good word. Cheap. I think the worst word I can use is reactive. I think the worst thing you can be, and I'm going to have my soapbox here, I think as a DBA or an engineer in databases, the worst thing you can be is reactive. You've got to be proactive. You've got to see changes coming down. You've got to be ready for them. Like when the new version of Oracle comes down, when the Microsoft SQL Server comes down, like this year, I think Microsoft SQL Server 2022 is coming out. And then next year, Oracle 23C is coming out. If you are not aware of what the changes are and what's happening there and how it's going to benefit your business, you're not doing your job in the world of databases. If you're not looking at the code, if someone changes the code and you're not looking at it, how it changed, and if there's a better way to do it, and you're just adding to it, there's something called, I call it sedimentary code. Like you have 1,000 lines of code, and you need to change it to do something. So rather than changing 1,000 lines, you just add 3 to the bottom. And I've got applications in my job. There's one that's got a stored procedure that I think at last count was like 87,000 lines of code. Because they just kept adding things to the bottom. And I have no idea how it still works, but it does.
We call that a spaghetti code.
I like that too. I like spaghetti code. I like spaghetti code. being more dinosaur related, I guess, like dinosaurs. I call it sedimentary, but spaghetti works too. Yeah, yeah. But anyway, I digress. So with joins, I mean, does anyone any questions about joins, how they work, how to look into them, how they function? Silence is consent. All right, sounds good. So that will end this week's lesson. Next week on week 5, we're going to talk a little bit more about this. We're going to talk about left and right joins very briefly. And then next week, the majority of the day, I will take you through the designing of a database and how one of the ways that I do it, just so you guys can see the experience of building it out from one table to the filtering out of other tables. If you are doing the project and you are just building tables right now or kind of sorting out tables, you're right where you need to be. You're doing fine. If you have any questions, shoot me pictures of ERDs, email me your ERDs, let me know what's going on. Text me or email me. You want to do a quick one-on-one session? I'm open most days for at least 15 minutes at a time. I'll log in and chat with you guys real quick. Please remember that I am in the Eastern. Now, Nicholas, you're like in Russia, right?
No, right now I already relocate to Montenegro.
Okay, Montenegro. But that's still like, it's still like 3 o'clock in the morning there, right?
It's 4:40.
Wow, dude, man. Okay, so at least you're in Montenegro, which is safer than Russia. Okay, so you're doing good. All right, so you be safe, Nicholas.
I attached my actual model to my homework last week. Is not how you want it done.
That's fine. No,
Okay.
no, that's you can totally do that. That's fine. There's a when everything is said and done, when you upload the final project, there's a link to do that at there, and I'll make sure you guys have that. But if you're just sending me your ERDs to look at, that's fine. Just link it into your homework.
Yeah, I
You
was
know,
just sending it with my paper because it's too big to put on a screen and take a screenshot, with all the tables.
Yeah,
And
it's totally fine.
so pretty much when I was looking at your thing on one of these joins you were doing, anytime you do an address, you pretty much have to make a table for state and city, right?
No, I don't. This is just the way this database did it. I don't personally like doing that. Oh, stop airing out. Okay, thank you. That's just the way this one did it.
Have that repetitive information on there.
Yeah, I generally, for me, when I do it, I don't even like putting the address in a separate table. I like putting the address in with the customer. I don't know why they did it this way, but you totally could.
Well, the way I'm putting down mine is the real estate one is a property address, and the property address has, it's just the whole address.
That's fine.
And so it's its own table just for the address.
Yep.
So it's okay to have the state and the city repeat constantly.
Yeah, because it's unique to that particular address. That's fine. I mean, I've seen people do it to where the only way that I've ever gotten behind doing it is if you make a table that's like city, state, and zip, and then link the zip code as the primary key to it. But I've never had a problem doing city, state, and zip in the actual address table.
I'm just doing a auto increment primary key, so
Yeah, that's
that
fine. Yeah.
it's nothing complicated, because there's really nothing definitive on a property address other than
Well, no, there is
there's no natural key unless you
having
join multiple columns.
well having been in the property biz, there's lot numbers and page numbers, and unfortunately you're giving me flashbacks to my days
I'm not
in
going
title
that deep.
insurance.
I'm just doing straight.
Yeah.
I'm just doing straight address. I'm not going that deep into it.
Yeah, and I don't blame you, because that is a giant mess. But yeah, no, that's fine. Yeah, you're totally fine. Address, city, state, and zip in the address table is totally fine. That's one of those, like, you know, you can argue the point with people, but it's not that big of a deal that it's going to cause headaches and normalization. It's totally fine.
Got it. Thanks.
Yeah. All right. Any other questions, comments, thoughts, concerns? Everyone see Doctor Strange last weekend? It's a pretty good movie, haven't it? I do recommend it. If not, all right, we'll call it a night, and I'll see you guys next week.
Okay, thank you.
All right. Thank
Bye,
you.
guys.
Bye.
Thanks.
Bye,
Have a good
Steph,
night.
can we
Yeah.
have a 5-minute after the class?
Sure, I'll hang on. I will stop recording though.